Good morning, it's me, Mr. Truman, back again for another video in geometry. Today we're going to be looking at the 30, 60, 90 rule, which is kind of our is the part 2 to our last video called the 45, 45, 90 rule. And in this case, we're going to be looking at a triangle that has a 30-degree angle and a 60-degree angle. And we're going to look at how the leg, there's going to be a short leg, a long leg, and a hypotenuse, how they're all related to each other. And so this formula is standard in any geometry textbook, and you'll find it on the SAT for college. They have both the 45-45 and the 30-60 on the formula sheet that they give you when you're taking the SAT to get into college. So how it works is we have a short leg, which we say has a value of x. Well, the hypotenuse is double the length of the short leg. So whatever we have for here, this one is twice that amount. And that makes the hypotenuse. And then the long leg is the distance from the short leg times the square root of 3. So that's kind of an oddball thing to show you. So I'm going to, or just to throw out there without explaining. So I'm going to do an example of a right triangle. I'm going to use the Pythagorean theorem. And if I happen to have one that looks just like this, I haven't written any angles in yet, but I just want to go over it. Let's say I have a side length of 7 for the short leg and 14 for the hypotenuse. Well, if I was to use Pythagorean theorem, I would have this value here, which is missing. So I'm going to make up a letter. We'll call it x. We'd have x squared plus 7 squared equals our hypotenuse squared. Well, x squared is x squared, but this is 49 equals 196. Well, if I were to take 49 from both sides, I would have that x squared equals, and I'm going to get my calculator out to show you, but I would have 196 minus 49, and I get 147. Well, the funny thing about that is if I have to keep that in what you call radical form, there happens to be a way to break that down. So like, for example, if I have x squared is 147, and I take the square root, well, there is no square root to 147 that's a whole number. But when I think about it, if I break it down, 147 is really 3 times 49. And I know what the square root of 49 is, it's 7. So I could erase this and say, well, that's going to be 7, and then I have a leftover radical 3. Well, if I looked at that, I would know that from the 45-45, this must be a 30-60 triangle. Because all 30-60 triangles have this very unique, and that's why we call it a special right angle, a right triangle. They have that unique relationship between each of the sides, so that if you just know one side, you can actually calculate them all mentally. You can figure out the little mental math there. That if I know this one, I know this one, and I also will know this one as well. So let me demonstrate how it works in a problem. If you look at my 4 examples up here, my first example, I have, again, 30-60, I've labeled it, and I gave in this one the shortest leg, the shortest distance, the short leg as I call it, and x is also a leg, but I call that one a long leg, and then I need to find the hypotenuse. Well, if I use the formula and I know that the short leg is x, well then I know that the hypotenuse has to be that value times 2. So that means that my y value has to be 2 times 8, which is 16. As for the long leg, again, if I go back to that formula, it says right on here that if you take the short leg and you multiply it by radical 3, you would get the long leg. So 8 times the radical 3. And that's actually all the values. Now, I could, if I had 2 of these, I could use Pythagorean theorem and figure it out like I did here, but I would need to know 2 values. And that's just called Pythagorean theorem. If I just know one value, I have what you call a special triangle. I have one that's very unique in that one number does them all. So that's how it basically works. We can work this in reverse. For example, if I know in number 2 that my hypotenuse has a length of 50, well then that means that the short leg would be 50 divided by 2, or 25. And the long leg here would be 25 times the radical 3. So again, that's how the process works. If I just know one, I can figure them all out. If we're on example 3 here, instead of giving you the hypotenuse or the short leg, I gave you the long leg. Again, you can work in reverse. If you know the long leg is 11 radical 3, like it is over here, well, I know that the multiplier is the radical 3. So if I just take 11 radical 3 and I divide by radical 3, they cancel and it tells me the short leg here is 11. And then I would know that the hypotenuse is 2 times 11, so that would have to be 22. So they all fit the mold pretty well. Every once in a while you get one that's really quirky, like this number 4 example, and it's a bit of an issue because I know that I'm supposed to, if this is the long leg, I know that I'm supposed to divide by the radical 3 to get me back to the short leg. The only problem is my 12 doesn't have a radical 3. So when I try to do that, I immediately hit a problem. I hit the snag that, all right, I've got 12 radical 3. 12 divided by radical 3. Well, again, I try to teach my students that in the future, as we move forward, that we all understand that in Algebra 2, we're going to learn a lot about radicals. And one of the first things we learn is that radicals and integers they really don't play well together when it comes to dividing. You can't take an integer and divide it by a radical. So we'll rationalize that denominator. We'll get rid of the radical by timesing it by radical 3 itself. Times it by itself and it'll become a whole number, an integer. The only problem is you can't just be randomly doing that to one without doing that to the other. So if I do that to the numerator as well, to make up for it, I would have 12 radical 3. Well, 12 divided by 3 tells me that I would have, the answer would be x equals 4 radical 3, because 12 divides by 3. So that one would be a pretty tough problem. It's probably one of the hardest ones we ever deal with. And then I know that if I have to multiply 4 radical 3 by 2 to get a hypotenuse, I would end up with 8 radical 3. That's our worst case scenario, but again, it follows by that whole thing about we can't divide by a radical, so we what you call rationalize it. I hope this helps. That's it for this video. I just want to keep it short, and again, just follow up to part 1 on 4545. Alrighty.